Today we're going to break down measurement system analysis, also called Gauge R&R. By the end of this video, you will understand the difference between the accuracy and precision. You will be able to calculate the repeatability and reproducibility variations, and at the end of this video, we will conduct a detailed average and range method calculation using a practical example. Let's start. Measurement system analysis, or MSA, is how we evaluate whether our measurement process can be trusted. The most common MSA study is Gauge R&R. And Gauge R&R asks one very simple question. How much of the variation we see in our data is coming from the measurement system itself? And how much is coming from the process itself? Now, before we go any further, we need to clear up one of the most common misunderstandings in quality. Gauge R&R focuses mainly on precision and not accuracy. But wait a minute, aren't accuracy and precision the same thing? And the answer to this question is no. Let me explain with a simple example. Imagine we're measuring a machine shaft with a specification of 20.00 millimeters. Now let's look at three scenarios. In the first case, the micrometer measures the shaft as 19.95, 19.95, 19.95. Every single time. Those readings are very consistent, but they are far from the true value. This measurement system is precise but not accurate. In the second case, the micrometer gives readings like 19.90, 20.05, 19.85, 20.10. Now the readings are scattered. This system is neither precise nor accurate. In the third case, the micrometer reads 20.00, 20.01, 19.99. The values are consistent and centered on the true dimension. This system is both accurate and precise. In MSA, we focus only on precision, as inconsistent data destroys our ability to see what the process is actually doing. So it is very important to understand that before you conduct Gauge R&R study, you need to calibrate your measurement system to ensure accuracy. Now let's talk about variation. Whenever you measure a part, the variation you see does not come from just one place. It comes from two sources. First, true process variation. Real differences from part to part. Second, measurement system variation. Error from the gauge, operator, or method. Think of it like this. Total variation, what you actually see in the data, equals process variation plus measurement system variation. If the measurement system variation is too large, it hides the true behavior of the process. That's why we say, you cannot control what you cannot measure correctly. This is where Gauge R&R comes in. Gauge R&R breaks measurement system variation into two parts. Repeatability, which is the equipment variation, symboled as EV, and reproducibility, the appraiser variation, or the operator variation, symboled as AV. Together they tell us how much variation comes from measuring, not from making parts. Let's have a closer look at the repeatability. Repeatability is the variation you get when the same operator uses the same gauge to measure the same part multiple times. Any variation here is mostly due to the equipment. On the other hand, reproducibility looks at something different. It measures the variation when different operators use the same gauge to measure the same part. So as said, repeatability problems point to equipment issues. Reproducibility problems point to people or method issues. And the measurement system variation, or the so-called sigma GRNR, is the square root of the EV squared plus the AV squared. So the does not only tell you that your measurement is bad, it tells you where to fix it. Now that we know what Gauge R&R is, let's see how the variation has been calculated in real life. Let's set the scene. We are measuring a shaft diameter. 10 parts, 3 operators. Each operator measures each part twice. That gives us a table of measurements. This data contains 3 types of variation: part-to-part variation, equipment variation, operator variation. In this example, we are going to measure the variation using the average and range method, the most commonly used approach for Gauge R&R. Now to start, we list our measurements in a sheet like this, then we move to the first step, ranges. For each operator measuring the same part twice, we calculate the range. The range is simply highest value minus lowest value. This range tells us how much variation occurs when measuring the same part repeatedly. At this point, we are mostly capturing repeatability, the equipment variation. Next, we average those ranges. First, average the ranges for each operator, then average across all operators. This gives us the average range, often written as R bar. R bar represents the typical measurement spread from the gauge itself. This is our first estimate of equipment variation. As the repeatability, or the EV, is calculated from the R bar using this equation, EV equals R bar divided by D2. But now wait, what is this D2? D2 values are predefined statistical constants. These constants obtained from this table based on the number of operators and the number of trails. Here in this table, M is the number of trials per each operator, which in our case 2, and N is the number for samples multiplied by the number of operators. So 10 samples multiplied by 3 operators is 30. Now in our example, the N value is greater than 15, which means that we should use the default values, or the so-called D2 prime values, at the bottom of the table. So this means for us that the D2 value for our example is 1.128. So we divide R bar by the D2 constant of 1.128 to get our EV value based on the number of trials. This tells us how much variation comes from the measuring equipment. Now we shift focus from equipment to people. Now we go back to our sheet, and for each operator, we average all their measurements across all parts. First, average the measurements for each sample. Then average across all samples. This gives us one average per operator. If those operator averages are close together, operators are measuring consistently. If they're far apart, we have reproducibility issues. Next, we calculate the range between operator averages, which is called R0, or the operator range. So the operator range equals the max operator average minus the operator average. Then, just like before, we apply a constant D2 to convert that range into a variation estimate using this equation. Here in this equation, N is the number of samples, which is in our case 10, and R is the number of operators, which is 3. But here in the AV calculation, the D2 value, the N in the table, is always 1, and the M represents the number of operators. So this means our D2 equals to 1.912. We take this D2 value and substitute in the equation. This result is AV, the reproducibility variation. This tells us how much variation comes from operator differences. And only now we combine the equipment variation EV and the appraiser variation AV like this to get the Gauge R&R variation. This represents the total measurement system variation. At this point, we've isolated measurement error from actual process variation. Finally, we compare measurement system variation to total observed variation. This gives us % Gauge R&R. This percentage tells us how much of what we see in the data comes from the measurement system. Lower is better. Here's the standard guideline. Less than 10% means that the measurement system is good. Between 10% and 30% means that the measurement system may be acceptable. And anything greater than 30% is normally not acceptable, because if Gauge R&R is too high, capability studies and SPC cannot be trusted. Even with modern software, this method remains popular because it's transparent. It's easy to explain. It works well for variable data. It's accepted by customers. Most importantly, it helps teams understand where variation comes from. This is why customers require Gauge R&R. Capability studies depend on reliable data. Control plans depend on reliable measurements. PPAP approval depends on reliable evidence. That's why measurement system analysis is not optional. It's foundational.
If you found this video helpful, don't forget to give it a like and drop a comment below. We'd love to hear your thoughts or questions. And if you're into leveling up your skills with expert-led content, hit that subscribe button and turn on notifications. For full courses, downloadable assignments, and certifications, head over to excetify.com. Start learning smarter today.